everyone, welcome to another awesome day of FileMaker Training. I'm Richard Carl here of fmtraining.tv, where I've been busy at school studying to be very, very smart. My head's hurting. I don't even remember what I hardly did this morning or yesterday. That's how much data has been filled in there. I'm afraid I'm forgetting things. So to help us remember today, we have a special guest star today who will be here to show us all sorts of exciting details. I've been seeing people talk about it for most of the week, and his name is HOnza, and we are going to get to you, HOnza, in just a second after I make a couple quick announcemements. First up, if you want to support the channel, visit fmtrain.tv. Check out one of our training bundles over here. If you want to see the upcoming broadcast schedule, you can see what we have going there. Monday is going to be kind of an interesting conversation. We're going to be covering kind of a retread or update of the Claris platform, which is kind of this new gee whiz stuff they're building in a web browser. We played with it about 2 months ago, and it was interesting, but clearly not fully baked. So we're going to take another swing at that. I'm actually working on the demo for it today. We'll see how far I can get in terms of functionality, but that's the idea, is to build out a demo. Now we're going to pivot to HOnza. HOnza's here. I'm going to quit sharing my screen. So we're going to have full HOnza. How are you, HOnza?
I'm fine, and I hope everyone is ready for the danger zone in this
danger zone
called the FileMaker calculations.
FileMaker, you know, I hate to break it to you, but I'm afraid I'm going to be bored out of my mind. I mean, nothing. I mean, it's just like FileMaker calculations. Like, oh God, do you have anything exciting, HOnza? I'm really not picking on you, but
yeah, definitely.
Should I get out a pillow and take a nap here? What is happening?
No nap. I'm going to blow your mind.
Blow my mind. Okay.
But before we start, I have a challenge that I shared a little bit earlier this week on the social networks, and just look at it and try to think about it during this stream. Basically, the challenge is here I am having a calculation in the beginning that produces a list of 10,000 random numbers, and my challenge to you is how quickly you can calculate the total of those 10,000 numbers in a calculation. And there is one extra
in a value list
challenge here, in that if you are supposed to produce something that also will work if I increase the number of numbers to 100,000. So think about it. If you're watching this from a recording, you can also pause the recording, try to come up with a solution, and then keep watching. But just think about it, and in the end, I will show what different people were suggesting and what the results can be.
I have a question. Yes. Is you have 10,000 in our first one, different random numbers in a single field, so it's a lot like a really big value list. Is that what you're saying?
Yes. Okay. Exactly.
As opposed to 10,000 records in a table, each one with a random number. Okay. Great.
Yeah,
okay, cool.
So it's a list of numbers in a string, in a variable, and the idea is how quickly you can calculate the total of those 10,000 numbers.
So we got 10,000 numbers that can scale up to what, 100,000 easily? Sounds like a while function or something, maybe. I don't know.
Yeah,
right. Knowing you, probably JavaScript with a while function with a unicorn blood. All right, cool.
So here's the challenge that I talked about. So this is a calc where in the beginning it produces the list of random numbers, and this blue part is what you're supposed to replace with your calculation. That's the challenge, and the whole thing returns a time in milliseconds, how long it has taken to calculate the total using your approach.
Okay.
So try to think about it, what your approach would be, and I'll keep talking about other stuff, and then in the end, I will share the results. So now let me show you something that I was working on recently.
It looks like a Commodore 64.
And
that was before you were born. Don't worry about it. All right.
Just zoom in a little bit so you can see it big. And basically what I was working on is a calculation that produces a PNG picture, PNG image.
Keep going. I'm interested. Keep going.
So here is the first version that I created. And this image that you saw in there, that was just a very small image, maybe 100 by 100 pixels. And now I'm running live the first version of the calculation that produces the image. And what I'm showing here is that it took me 14.5 seconds to produce this PNG. And what I'm going to show you how I actually work on optimizing calculations. And but let me take a few guesses. How small number? How much do you think I could optimize this? What do you think is the number that my version 6, which I will show later, how long it takes to
Stop for a
generate
second.
that?
Are that when you, all those numbers there, are those milliseconds, or are we looking at points or pixels?
All these numbers are times with fractions. So this is 14 seconds, point 55554.
Got it. So
And the individual times are portions of the calculation, and the total is what you're interested in. So just guess. Give me some numbers in
well,
the.
you'd want to cut the image down. You want to cut the pre-process down. If you cut those numbers down, you'd save a lot of time. So I don't know.
Yeah, definitely. But how I got these numbers? Let me show you in the data viewer. Let me, if you will see something, but here's the calculation that I took. Basically, what I do is if I'm working on the custom function, which in the first version it looks like this. It's a lot of complex calculation, and you don't have to worry about it too much. I'm just going to show a few details. The point is that when I debugging or optimizing a calc, I take this, copy this, and paste it into the data viewer. And basically, I simulate the parameters of the custom function by putting them, if there is a let or while function, I put them in the beginning. Otherwise, I just add the let function to simulate the parameters with local variables. But the main point here is I'm using a few additional assignments where I collect the timestamp. I'm actually using Toolbox plugin, the 240 Toolbox plugin, because it gives me timestamp with microseconds precision, unlike the built-in milliseconds in FileMaker. This lets me benchmark even the fastest calculations. And I put those benchmarks in the middle of the calculation, where I basically split the whole process of calculating whatever I am calculating, and in the end I'm just returning all those measured times as a result. So when I evaluate the calculation, I get the individual times here, and this way I can tweak the calculation and immediately try it out and see what the effect of the tweaking is.
Okay.
But the thing here is, obviously, you pointed out that what takes longest time in this first version is the preprocess time and the image time. And basically, those are two while loops where I am going through numbers. In the first place, it's basically the list of all the pixels that I'm going to render, because this calculation takes a list of numbers, each number representing a color and opacity of a single pixel in the image, and goes through the list of the numbers and produces the image. So the pre-process goes through the whole list of the pixels, analyzes them, and discovers whether there is any color used, whether there is any opacity used, because PNG supports different formats and can optimize the size of the image. If it's only grayscale, if it has only a small number of colors, then the image can be smaller. So this pre-process does this analysis, and the image part actually converts the pixels into a valid PNG format in terms of producing a valid deflate format, which is the one that Zip uses for compression. And those are the two while loops where I iterate through the images. And in the first version, I was simply iterating and using the get value function to extract the single pixel value from the long list. And so in order to make it faster, I started thinking, okay, so what the get value is taking in terms of time. And as you can imagine, get value, when you try to go through a very long list, because get value takes the list separated by carriage returns, and when you get a list of 100,000 values and you want to get the number which is number 99,999, whatever, the get value function has to go from the beginning and start counting all the carriage returns until it reaches the right number that I'm looking for. So it was kind of natural for me to expect that the get value function gets slower as the farther I'm looking in the list. So extracting the first number from the list is very fast, but extracting the last number, I was assuming is the slowest one. So I was thinking of replacing the get value with a different function, such as middle, or and so my assumption, and this is an assumption I was making for the last 20 years, that when you have a middle function and you give it the parameter, the initial offset where you want to extract the substring, then there is nothing it has to do with the preceding part of the string. So it can go straight to the offset and extract 5 characters, like in this example. But what I discovered when I was trying to optimize my calculation was that this assumption was wrong. And that was extremely big surprise for me. So I tried to measure what it takes to calculate get value, what it takes to calculate middle. And actually, when I use the middle function iterating through the long list, and here I'm showing the chart taken just from going through 10,000 values. With the middle, I got actually significantly worse result than with get value. And it was not linear. It was getting slower with the farther I was looking into the string, just like the get value. And that was extremely surprising for me. So I got an idea to do it differently. My idea was that I take that long list, and every time I process the first value from it, I just deleted it. So I work with it just like with a buffer. I take the value and remove it from the list using the replace function. So the replace function, basically, you give it the offset and the number of characters and string you want to replace it with. So I took the first 10 characters, which represented the number.
And that's still faster than using middle, doing it that way?
Well, that's the winner here. That's the line in the bottom.
I know, but I'm just shocked because
yes,
I mean I understand that left or right could be faster than middle.
It's not only
but left and a replace, or a left and a truncate, or whatever you're doing to get rid of the data. So no matter what you're doing, it's always left, right? Left.
Exactly. So this is extremely faster, even though you are basically modifying that long list or making a shorter copy of it, removing first few characters from it. So that turned to be the fastest one. So when I tried that and applied it to my PNG calculation, and let me check which one that was. I think it was version 2 or version 3. So version 2 here, PNG. So yeah, so version 2 was that I created replacing the get value with the replace approach.
Okay.
So calculate the same function again.
It's about half, right?
And the result I get, sorry, I need to zoom in.
Yeah.
Zoom in, zoom in, zoom in.
There you go.
So
you went from 15 seconds to almost, well, about 5. So
yes.
Yeah.
So this was my first optimization. I just got rid of the get value and started replacing the first value with empty string, taking it out of the buffer. And then I thought, okay, so what can be done next? So what I tried is, I tried to find out what the different functions actually take to evaluate. So instead of now iterating through 10,000 numbers, I was just taking a list of 10,000 numbers or 100,000 numbers. And I was trying to figure out how long does it take to calculate a single time, calculate get value, middle values, position, middle, replace, whatever, depending on where I'm starting in the list. And this was that great surprise. Except for the get value and maybe middle values, all these lines, all these lines in the chart were supposed to be flat lines. So there is something wrong, obviously, with how these calculations work in FileMaker calculation engine. And after this stream, I'm going to actually report it to Claris as a bug that I'm hoping they fix it, because that's not how these functions are supposed to work. So that took me to posting that challenge in the beginning of this week, and I was wondering what people come up with. So I tried to work more on the PNG, and the next thing that I tried in the function, so was version 3. Okay, so version 3, because I wanted the custom function to be practically usable, I need to come up with something as a structure that can hold the pixels values, that I can work with it, like addressing specific pixel, like saying, I want to change pixel 100 pixels from left, 50 pixels from top to the red color, for instance. So I needed a block of values that is easily to address. So I came up with a simple JSON structure which would hold the width, height of the image and the actual pixels. And I tried to turn it, use this, modify the calculation to use the JSON. And when I tried that version 3 with the JSON, it got actually slower again. So now it takes 7.5 seconds to calculate the image. So I was thinking, okay, let's try instead of having the pixels as decimal values, I will try having hexadecimal values, and instead of calculating, because each pixel is a RGB and opacity, so it has 4 numbers, red, green, blue, opacity, and this is all combined into a single number. And I was using mod and int to extract those individual values from that single pixel. So I was thinking, if I store the pixel as hexadecimal value and just use the middle or left to take 2 characters representing each component of that color, that it might be faster. So I tried another version, and that another version with the hexadecimal values that was even slower than the decimal values. And but by the way, this actually was the version 3. It was converting to JSON and also converting to hexadecimal. So I went back to decimal values where this was my discovery that FileMaker is actually much faster working with arithmetics than it is working with substrings. So it's much faster to divide two numbers, even if they are big numbers, than to extract first two characters from a string.
That's
So
interesting. That's very, very interesting. Yeah.
So I returned back to using decimal values. And in order to keep them easy to address, I simply aligned them with leading zeros to make each pixel value to be 10 digits, followed by a correct return. This way, every pixel sits in the exact place in the string, so I can easily modify it with the replace function. And I am dealing with decimal numbers instead of hexadecimal. Now, the final thing is, I run this challenge this week, and now it's time for evaluating your guesses. The only person that provided some guess was TopCat19 in Discord. I don't know how many people guessed in the other channels, but now I'm going to reveal the final time that I got to after applying additional knowledge I learned from running that challenge on the social media. So what do you think I got with version 6 in terms of time?
Well, in terms of that chart, I mean, if that chart's, you could be down to less than a second if that chart is accurate, right? For a larger image. Yep.
So running and 1.6.
Yeah, that's pretty.
So
that's a huge improvement.
So from 16 seconds in the first version or 15 to 1.6 after all the optimizations. So this is what I achieved with the PNG generation. And as you can see, image is still the major bottleneck here, but the pre-process got down to just half a second. So I'm not sure how much farther I can get with the optimization, but this is already pretty good, because if you want to use it for something like progress bars or simple charts where you really only have one dimension, you can have a PNG that's 1 pixel high and 1000 pixels wide. This one has 200 by 100 pixels, so that's 20,000 pixels. If you generate an image that has 1000 pixels, that's going to be immediate.
Yeah, instantaneous. So, I have a question. Aren't you the one that was talking about some of the JavaScript calculations being much faster than the built-in FileMaker? Wasn't that you?
That was me.
So I was thinking that you were going to say something about JavaScript in here, offloading this to JavaScript and having that run. Because some of the people here, Dimok and, well, Ruben's not here, but some of these folks here, Stu, etc., they have a background in technology that's not necessarily FileMaker, right? So if you could write the calculation in JavaScript, would that be better in this case? Probably, I would think, right?
Yeah, definitely. It would be maybe 100 times faster. But today I was not going to talk about how to get faster by replacing a bicycle with a Ferrari. I was going to show that you can leverage what the bicycle can do if you know how to use it.
Okay, cool. I was muted, but yeah, okay.
So this is a cool PNG generation function, and I guess every FileMaker developer is now going to create a PNG generation function, right? No, not at all. But I was thinking, okay, I learned something new. Even after the 30 years of my practice, I learned something new, and I got surprised by my primary assumption about position and middle functions being wrong for all the time. So I was thinking, okay, how does this apply to something that's something more practical, something that many people are using? And I came up with thinking about virtual list. So just to remind people what virtual lists are, virtual list is a technique developed by Bruce Robertson, if I recall correctly, many years ago. And primarily nowadays it's primarily used as a technique to optimize performance of FileMaker solutions when connecting over the internet to the FileMaker server. So when you have a network where the latency between the client and the server, that is the time that it takes for data to go to the FileMaker server and then from FileMaker server back to the client, when the time is long, because anything that you do in FileMaker natively, the client keeps chatting with the server. Hey server, give me some data. Hey server, give me this. Hey server, do this for me. And just to display a single layout with few records, you can easily get FileMaker send maybe 100 requests to the FileMaker server in order to accomplish that task. So virtualist is a technique that's supposed to minimize this chatting between the client and the server to a single request and single response. So the idea is that from client, you send a request to the server, hey, give me this data, and the request contains the parameters such as what kind of data it wants, and on the server, typically you run a server-side script that gets the data, compacts them into a single string response, and sends that string to the client. And then on the client, you have a string containing, for instance, a table with 100 records, 5 fields in a single string, and you need to display it somehow. So the way how you do it is that you have a dummy table with empty records and unstored calculations that extract those data from the string. So once this gathering data from the server is done, you are actually using the calculation engine heavily to work with the data on the client. And so I was thinking, okay, if we, or at least me, if I was doing something completely wrong with calculations for the last 20 years, and I now know how to optimize even optimized calculations to run 10 times faster, how is that going to apply to working with virtual lists? So I got this database. Here it is. Speed test, virtual speed test. So this is a database that's a copy of public database shared by the government in Czech Republic about schools. It's a practical example. We were using this database just a few months ago when building a business plan how to sell more iPads to schools in Czech Republic. And this database comes with some useful numbers, such as for every school, how many kids they have, how many computers older than 10 years, how many computers old between 3 and 9 years old, and so on. So I took a few fields here, like the number of kids, the number of IT staff, number of equipment, and I built a calculation, typical way how to run the how to get the data from a virtual list. So when I open the database definition here, I came up, and a few years ago I already shared that probably the fastest way how to get virtual list data from the database is to construct the data, compact them into a single field, and then use the list summary to extract the data from there. Anyway, there are multiple ways how to do it. So the most easy to use, or the most obvious, is starting FileMaker 16 is to produce a JSON structure. And that JSON takes every field, it has a name in it. So when you look at that JSON, you understand the data, you know what there is. But getting the JSON and processing that JSON works very well if you have like 10 records. But if you have 7,000 records, like in my case, it's significantly faster to process the data if you get it just as tab delimited values separated by character returns. So I also implemented that thing. So let me run the test here live and show you what it takes to calculate to get the data. And so
Yeah, people are saying
JSON,
it's better. It's good. All right, so you're good. Keep going. Keep going.
okay. So here I have a calc that takes the data in JSON, and to somehow compare what it takes. So what I decided to do, let's go through all the list of the 5 fields and calculate the totals, like total number of kids, total number of staff, total number of computers, and calculate the totals from all those 7,000 something records. So, and here, by the way, you can see another cool trick where what I'm using when testing calculations, because if calculations take a long time and you leave them in the data viewer, it can kill your FileMaker when you keep the data viewer open, because it will keep re-evaluating all those calculations. So it's always good to have some case and some switch here, like this false, which disables the calculation until you want to enable it and recalculate it. So here I change this to true, and I will enable the first test and hit evaluate. And now what's happening is that there's one more switch which is global for the whole calc. So here I hit evaluate, and now what it's doing is it extracts the 7,000 records from the database in the JSON format, and then goes through all the values in the JSON, extracts those values, which is what FileMaker would have to do anyway if you want to display the data. And additionally, it also calculates the summaries. And I don't know if Zoom is showing the spinning
It is.
rainbow.
Yep, we have the spinning beach
Rainbow
ball.
wheel, but
Yep.
yeah, so now you see it's taking really long time to process those 7,000 records. This is, by the way, the reason why most implementations of virtual list also implement paging. So virtual list typically never displays 7,000 records. They display like 10 or 20 records. And if you need more, you have to switch to the next page and so on. That way, virtual list implementations minimize the need to evaluate the data over and over again. But anyway, sometimes you need to process something like calculate summaries or do filtering or whatever. And 7,000 records really isn't so huge list. It's a relatively reasonable. We sometimes work with much more, but as you can see with JSON, it's taking really long time. It may take about additional minute. So maybe if you have a question, now is a good time to ask it, because now I can answer questions. And I have
Yeah, because we're waiting for it to go. So questions, Stu? Any of you folks have questions? There was a little bit of a conversation earlier about that memory leak that was found and was submitted on Claris earlier. About 3 or 4 days ago, it was the memory leak about the submitted the Claris community page about memory allocation, a memory leak since FileMaker 13. If they define a variable with a large block of text, and they're using left functions and allocating money.
Yeah.
I don't know if you've seen that conversation or not.
Yeah, this memory leak is something that I really didn't know about until this week. And I learned about it after I posted that challenge, and someone came up with a method how to calculate the total of 10,000 numbers faster than me. So I was wondering what the method was, and I think it was Josh Willing who mentioned that that link to the conversation about the memory leak. And the memory leak is basically that many FileMaker calculations, many FileMaker functions, which work with strings. When you extract the substring, even if the substring is significantly shorter, FileMaker actually allocates the enough memory to accompany complete copy of the original string.
Okay.
So if you have a list of 10,000 numbers and try to extract first 10 characters from that list, it will still allocate memory to hold all the 10,000 numbers. But there is also a trick that if you concatenate the results of this function to an empty string, it will actually drop that allocated memory and keep only those 10 characters. And that trick is something that I also used in the final calculation of the PNG. Another one was, and it wasn't so visible in the charts, that there actually is a function which is amazingly fast, and that's the middle values.
Middle values, okay.
Even from that string holding 100,000 numbers, extracting a piece with 1,000 numbers from that with the middle values takes almost no time. It was like 5 milliseconds, or maybe less. So that middle values function is extremely fast, and that's extremely efficient. And what I also discovered is basically functions that were added to FileMaker recently in the last few years are probably better written than those ones that exist for 20 years.
Okay.
But anyway, now here I have the results.
Okay.
And as you can see, working through the JSON structure holding the 7,000 records took me 3 minutes and 1 second. So the second test I have here is the same thing with the tab delimited values. Basically, I have every record is a line of text with I think 6 fields with the name of the school, number of kids, number of staff, equipment, 10-year-old computers, 3 to 9-year-old computers, and 2-year-old computers. And I'm extracting those values simply by taking that single line using, in this case, get value, substituting the tabs with carriage return so that I can again use get value to extract each field. So instead of JSON, I'm using a plain text, tab delimited values, and return delimited records. And guess what? How long it takes to process that? So if you have a, so let me enable this test. And if you have any questions, any more questions, you can ask them now, but you don't have so much time for my answers because this will be much faster.
Okay. Obelix on YouTube had a question. He was talking about, Margaret, I don't know how long ago that was, right? By cut 5 minutes ago, right? So 7 or 8 minutes ago for the question.
Probably.
The calc is done, by the way.
Yeah, I know. It's already faster, right? See, so there you go. Yeah.
So it took just 7 seconds to calculate using the tab delimited values. I was still using get value with that long list, but just by not using JSON.
So wait. So that when these JSON functions are fairly new, they should be pretty fast. So why are they going so slow?
Well, because they have a lot to do, and by the way, they still make that extra copy, extra memory allocation. So I think that was another reason why the JSON get element is slow, because that memory allocation bug is even in the JSON functions. But basically the structure, the JSON always takes the string representation of the JSON as a parameter and needs to parse it. It doesn't have it parsed in the memory. And that was another suggestion that I made last year, or maybe early this year, is that FileMaker finds a way once it parses the JSON internally. If it's still in the same variable and if you don't modify it, it would be better to keep it in the memory parsed so that when you next use the JSON get value on the same JSON, it will just reuse that pre-parsed binary data from the memory instead of parsing that whole JSON again.
Yeah, we're getting into some pretty advanced ideas because somehow you'd have to. I mean, because if you had the conversation with Clay, he'd go, "Well, how do we know that we're going to use it again, and why should we dump it?" Right? And then it gets to this issue of, well, maybe we should tell you not to dump it, but then if they don't dump it, it occupies memory. If they dump it, they have to reprocess it. Yeah.
Yeah, it's advanced stuff. So in some cases, like here, simply falling back to the older simple stuff like tab delimited values can be a good solution, but still 7 seconds is a lot. How low can we get? What do you think?
Well, I'm going to ask Oblex on YouTube to give the answer because I stole his answer last time by accident, but I want to give him a chance to answer the question here. It's about a some odd second delay. So, Oblex, you want to give me an answer real quick? And then we will. Yes, other people are thinking about JavaScript too, and having some of this, it was a suggestion that you made. Did you talk to Clay? Let me ask, I'm going to pivot here just briefly while I wait for an answer on that. Did you talk to Clay or some of the programmers at Claris about using some JavaScript kind of function capability as opposed to rolling their own to make things faster? Or was there any conversation there with that, or did that not go anywhere?
Not really. A little bit on the Claris community, and I think the one great way would be incorporating something like Node.js inside FileMaker because the main difficulty with JavaScript currently is that it needs to be used within web viewer, and that's quite obstacle for many people. If you could just have a function evaluate JavaScript and that work, and because Node.js is a server-side JavaScript basically that can do this, so we have a way how to do that. That would probably give us a lot of power. But let's come back to the native FileMaker calculations that we have now, and let's see where we can go. So as this week or last week, I learned that FileMaker is much better with numbers than it is with strings. I got an idea. Okay, when I am getting 1, 2, 3, 4, 5 number fields, instead of getting those number fields separated by tab, what if I combine them into a single number and extract that single number by these calculations? Like, so if I know that each of those numbers is just within some limits, like there is no school with more than 10,000 or more than 99,000 kids here, so I can say, okay, this number will not be more than 5 digits long, and so on. So I can combine all those numbers into one. So I tried that, and what do you think? What the time will be? 7 seconds.
I was going to guess less than 2 seconds, but we'll see.
It's not so much, I think, but like not so.
David Angel says 1,000 times faster. So
yeah, but it's 4 seconds.
So okay.
So that's this. Then I actually got to this week because this is all I did last week. Now I got to this week. I posted that challenge, and I got these interesting responses. And also I did that finding that actually replacing when I'm processing the list of numbers and replacing the first one instead of using get value can give me better results. I said, okay, let's try. So what time did I get if I replace the get value, if I get rid of the get value and apply this optimization? And I got.
Yeah, I'm not seeing him. You're asking questions fast and these guys are responding. So yeah.
So I got less than a second.
Wow, that's better. Then
So
three. And then remember that your top one was 3 minutes. Is that correct?
yes, 3 minutes with the JSON. And then I got those different ideas from the different people as part of the challenge, and I tried to optimize it even further.
Wow.
And the result is 267, 68 milliseconds.
A quarter of a little over a quarter of a second. Wow.
Yeah.
That's pretty quick.
So I have the results to show here. So basically, getting the data from the server, tab delimited text was about less than half of the time for getting the JSON. Numbers combined, that was a little bit slower, but as we know, this is still a short time to get the data, just like quarter a second to get those 7,000 records. But to process those records with tab delimited and numbers combined into a single number, I got just 3 seconds instead of 3 minutes. Just numbers combined instead of using substrings, that was almost twice as fast as using the substrings. When I got rid of the get value, I got it 15 times faster. And when I implemented, and I will show you what I'm talking about, chunking, which was one of the ideas that was used. Instead of working with the long list of 7,000 records, I used the middle values, which I learned to be very fast, to split that list to smaller lists and work on the smaller chunks.
Really?
So with this chunking, I got it another 1.6 times faster. And the final result was almost 700 times faster than the JSON one.
Yeah, 2 minutes is a long time. I mean, anything that's less than 3 or 4 seconds, typically people won't complain about if they're waiting for it to happen. But 2 minutes is like they think their computers crash or the servers crash or something. So yeah.
Yes, definitely. So this is my answer to the question: how would my findings apply to the real world used solutions like Virtualist, and even the Virtualist that I considered fast, with tab delimited text being processed in 6 seconds for 7,000 records. Even from that, applying the new knowledge after 30 years of experience without any change on FileMaker side, I could get down to 200 milliseconds. And that blew my mind.
Yeah. That's pretty fast. So on the chunking, writing the chunking routine would almost be a whole live stream in and of itself. It's kind of an advanced idea.
Yeah, and by the way, the chunking is the trick that works around what I consider the bug in FileMaker, making those functions which get the offset as a parameter and still somehow, for some reason, they process whatever is before the offset, even though they don't have to. And the challenge that I posted in the beginning. Now, these are the different times for calculating summary of 10,000 numbers and alternatively 100,000 numbers. What I got from the different methods from the community. So the first 3 are extremely fast, but they can only be applied in very special cases. And that's if you have a list of 10,000 numbers, if you replace those carriage returns with the plus sign, you get a valid calculation, and you can use evaluate to calculate it. So for those 10,000 numbers, I got 12 milliseconds, and the first person who submitted this was Josh Ormond, if I recall correctly.
Yeah, I've watched him try to type a couple comments, but they didn't come over, so he's floating around somewhere.
Yeah. So the problem with the simple evaluate is that it only works with a limited size of calculation. Normally, in the calculation dialog, the calculation cannot be more than 30,000 characters. I think the evaluate accepts 100,000 or something, but it's still very limited. So you need to apply the chunking even to evaluate if you want to use it. But still, evaluate is something that can only be used if you can easily convert the string that you have into a valid calculation. But if you need something more complex, where you literally need to iterate through the values with the while function, then these other things apply. So with get value, it's way long. I didn't fit the chart here. It would be somewhere outside of this building. With chunking applied, as Josh Willing suggested, it got 121 milliseconds for the 10,000 numbers and about 8 seconds. Okay, this was actually chunking suggested by someone else. I think it was Mickey Woods or maybe Daniel Wood. This was simple chunking, but not working around that memory leak yet. This was the replace idea that I came up with last week. So that was 100 milliseconds for the 10,000 and 4 seconds with 100,000 numbers. Then Josh Willing suggested optimized chunking, where he used the middle values for the chunking, and he also applied the trick to overcome that memory leak issue, and he got to 70 milliseconds with the 10,000 numbers and less than 2 seconds with the 100,000 numbers.
Wow.
And then we combined our approaches, the optimized chunking and my replace idea, and we got even to half that time with this combined approach.
Josh says the chunked evaluate with a secondary evaluate can accommodate 10 million values, is what he just posted.
Yeah,
very smart people. For those of you who are not following all this, very smart people racing each other and creating a calculation formula that will perform at speed, and that's always
so here is the winning calculation that scored the best without using evaluate. So obviously the evaluate is much faster still, but we got very close to what the evaluate was returning with this approach, which can be used also for different kinds of tasks that cannot be simply evaluated with substitute and evaluate. So this is the answer to the challenge in the beginning. And now I'm wondering if someone can still come up with a faster approach without evaluate, but that would be probably unlikely until FileMaker makes some fixes. Oh, Claris, sorry. Just a few takeaways from my lessons this week. JSON is easy to work with, but tab delimited text can be a lot faster. Interesting discovery that FileMaker is much faster with numbers than it's with strings. And because of that, memory leak is actually very poor with long strings. So these functions are good to definitely avoid with large lists, while replace to delete the beginning of the string when you have it processed, and middle values for chunking. That's the killer technique.
The killer technique.
And the one thing that I keep learning all the time, even if I find the fastest way, someone can still find a faster one.
Well, so that's the problem when you put Josh and Wim in a room and yourself and a couple, and then like Klaus Levent, someone's always going to whoop your ass and go faster, right? So
yeah, but the most interesting here was that the winning calculation was actually combining two techniques together, mine and Josh Willing's one. So so that's what the community is great for, that working with people together can produce even smarter ideas that a single person can come up with. And finally, a few links. to share. The
There we
first
go.
one is the download link for all the files that I was showing here. You can get a copy and play with them. The second one is my idea I suggested to Claris to make the calculation engine significantly faster. So if you haven't voted for it yet, go to that URL and give it
Oh,
your
is that one of their idea collectors where people can upvote the idea? Is that what you've got there? Where you can upvote the idea at Claris on their community forum?
Yeah.
Right.
And if you have any more questions for me now or later, and you can always come schedule a call with me, and I'll be glad to talk to you.
Why don't you, real quick, so obviously you're not making a lot of money on writing fast calculations. Why don't you show us what your products and offerings are for the rest of the community? People want to know, how do you make your money, and what should I buy from you? If I was going to buy something from you, what would they buy from you?
Okay, if you want an easy buy,
There we go.
On the website, we have tools here. So those are our products that we offer.
I still have to do the door thing.
So what we do most is hardware integrations and optimizations. So if you want FileMaker to talk to a piece of hardware, whatever it is, then we probably have already tried that, and we know how to do it. We have a few developer tools. FM Bench is for optimizing and for benchmarking solutions, but it's also great for collecting logs of what people are doing. And I discovered that it's even more valuable as a troubleshooting tool, because when someone calls you, I have a problem, and you try to ask the user, what have you been doing? They don't know. But if you have this tool and you have the log, you can just look in the log and say, okay, you press this button, then you click this button, then you run the script, then you switch the layout, whatever, and you know what the user was doing, and you can easily replicate this their issue. So that's a great thing for troubleshooting, not only for optimization. Bench test is our free tool to benchmark your setup, your FileMaker client, your server, and compare, see how it compares to the rest of the world. You can submit the results. They are immediately published on the website, so you can compare them with the results published by other people. We have already hundreds of records there, so you can see how Macs compare to Windows, how M1 compares to Intel, how different web hostings FileMaker hostings compare, etc. And the other tools here are Xcode.
Don't forget to show that one. That one's a good one.
Xcode lets you easily build a native app for iPhone or iPad from your FileMaker app using the FileMaker app SDK without having to deal with Xcode. It's an acronym. Go stands for Go. But it comes from Xcode, which is the Apple's tool for developers. For normal people, we have Xcode, which is an online service where you just drag and drop your FileMaker file. And
we've demoed this before. This is good stuff. So yeah.
So and you can read about all this in our news. We have articles, and one of them is actually covering the 5 live stream we had with Richard about this building of apps for the App Store, with links to every individual topic. So you can watch those videos and learn how easy it can be and how you can get your app to the App Store, which is built in FileMaker. But these are the tools you can immediately buy from us. But what we make money from is providing services, mostly from service level agreements, where we get a customer who has a FileMaker solution, and we take care of this solution in a long term, keep improving it, keep making sure that it runs without problems. So if someone has a FileMaker solution they have built themselves, or with a developer who is no longer available, or even still available but doesn't have enough capacity to to push it forward. That's what we primarily do, and where we focus our services. So
can I make a request? I want to hit this again. I haven't had a chance to do this, but I want to re-request this. So HOnza's got some hardware integration, and one of the hardware integrations I wanted to do. There's all sorts of really goofy hardware integrations you can do, like talking fish and beavers from Caddyshack, or whatever they were, gophers from Caddyshack that talk. But I very much, can you send me the link again on the recommended door lock? Because I want to be able to swipe a card, a mag stripe kind of card, or a near field communication, and have it unlock a secure door. But we're doing the back end, we're managing it with FileMaker. That would be really cool. And so if you could shoot me that, we build something like that, that would be a really fun one, because I have a couple places I would put this on without a doubt. I've already switched my house to a keypad, right, on the front door, and which is great.
Have you already forgot the password?
I have not. I'm not going to tell you about that. I have not forgot the password, but yeah, so you could do it with a smart card, right, or a near field card, right? You could do it with different things. Yeah, smart cards. Yeah. So yeah, there's all sorts of stuff you can do here. So I want to be able to unlock, have it check the database, make sure that I'm still an authorized person, and have it unlock the door would be great. I think that would be awesome. So
yeah, and the easiest way how to implement that is using fidgets. Okay. Because they are very easy to connect to each other, and with our bridge for fidgets, you can easily control those devices. So that's easy to work with. And if you go to news, and here you can filter by tags. So you can, let's say, go to where is hardware, hardware. And here you get all the articles about different hardware solutions, and most of them come with tutorials how to do that.
Okay.
So this is the latest one I did with fidgets particularly, which was basically having connecting temperature sensor to your server, and automatically switching fan. In this case, I was using a small USB fan as a demonstration purposes, but you can also switch air condition, for instance.
I think I could have a lot of fun with that. All right, cool. And then down there a little bit further, you were growing cannabis and shipping cannabis worldwide. Scroll down a little bit. Where was that at? I thought you saw that. Where was that at? Where'd you go? Oh, there we go. Right there. He's so if you want to get high, there we go.
Actually peppers, actually.
Oh, those are peppers? Okay, never mind. David Angel says, fidgets an electronic controller like Arduino. Is that the question? Yes? Yeah, there it is, bridge for Arduino. Okay. So, but you're saying fidgets is easier?
Definitely. The main difference between fidgets and Arduino is that Arduino is basically hardware that comes and doesn't know anything, cannot do anything, and you have to first program the chip to do what you want it to do, which is great for hobbyists. But the fidgets is almost plug and play. So you just get the box, you connect the cables, and it works.
I have a very short attention span, right? Very short attention span. So for me, it's the fastest I can get it done, the happier I am. So
yeah. So we also did the Arduino integration, and we basically built our own firmware that you can load into the Arduino chip to make it talk to FileMaker.
Really?
But even with this, which is probably the top of easiness, it's still more difficult than fidgets.
Okay. All right, cool. Well, if anyone gets any hardware going, let us know. We're going to want to demo that. Josh Orman's bouncing around. If he has any thoughts or ideas, let us know. Good job, HOnza. There we go.
Got there. Thank you very much, HOnza.
report of an individual up here who may be a FileMaker license. Well, it's potentially expired. Look at the back of that car right there. Looks like the FileMaker license has expired. Sir, I need you to step out of the vehicle. Sir, step out of the vehicle. Sir.